everybody, welcome back to my channel. This time I have another classic amplifier made by Rockford Fosgate. This time I got a Punch Power 800 A4, which is rated 100 watts into a 4 ohm load per channel of continuous output power, all channels driven. And as you know, I always test with all channels driven. The first test is 4 ohms per channel of continuous output power, 1 kilohertz. I bridged all 4 channels, so I bridged the fronts to 8 ohms and I bridged the rears to 8 ohms. That means every channel, every single channel sees a load of 4 ohms. And let me adjust the scope so we can have a look at the clipping behavior. Oh, clipping occurs. I go back, go to this one and fine adjust the input signal to this point. I take this one and we have a maximum voltage of 65.6 volts, and I verify with my cursor if it's true. Sometimes my maximum indicator shows some distortion and I don't want to have distortion. I take the upper point. It shows maximum 65.6 volts. I go to this point here, that's true, and it shows 64 volts. Let's calculate what the amplifier is doing with 64 volts. I got 262 watts bridge mono into an 8 ohm load. That means just 131 watts of continuous output power per channel into a 4 ohm load. Let's check out what the amplifier is doing dynamically. And now dynamic test 4 ohms per channel with 20 cycles. And you can see all cycles are the same level, no clipping, everything is alright. I think I got almost 68 volts, 67.2 volts. With 67.2 volts we have 289 watts. That means 145 watts per channel into a 4 ohm load of dynamic power with 20 cycles. The next game is the same test with just 8 cycles. Dynamic power, 8 cycles. And it shows 69.6 volts. And we have 68.8 volts. We have 303 watts bridged mono 8 ohms, and that means at 4 ohms per channel we have around 151.5 watts of dynamic power with just 8 cycles. Now I play the game with just 1 cycle. I take a shot and we have no clipping and we are at 70.4 volts maximum voltage. But I want to check out what my cursor will say at this position on the top of the positive waveform. It's 69.6, and then we have 310 watts bridged mono 8 ohms. That means 155 watts per channel into a 4 ohm load, all 4 channels driven. And I forgot to measure the efficiency. Here you can see the idle current of the amplifier, it's around 2 amps, and now I give full power, continuous output power 4 ohms, all 4 channels driven, 1 kilohertz continuous, and we have 62.1 amp. We have an efficiency in continuous output power 61.6% and dynamic power 68%. And now I switch back to a load of 2 ohms per channel. That means the front channels bridged mono 4 ohms and the rear channels bridged mono 4 ohms. That means every channel sees 2 ohms. All values I get out of the amplifier in this case have to be divided by 2, and this is the output power per channel. So I start continuous output power 2 ohms per channel. The voltage meter says 55.2 volts, but in my case I have 54.4 volts. This is 378 watts. That means 189 watts per channel into a 2 ohm load. The amplifier is rated 200 watts per channel into a 2 ohm load. The problem is that my power supply doesn't have enough muscles to drive the amplifier. when I test in dynamic power mode, it's no problem for the power supply. Now I try to check out how many amps the amplifier is pulling out of my power supply with all 4 channels driven to 2 ohms. 100 amps. That's crazy, 100 amps. My power supply is rated 50 amps and for a short time 120 amps. Dynamic power, 20 cycles into a 2 ohm load, and I catch one. Yes, we got it. That looks pretty clean, no clipping here. And let me take a look at the maximum voltage. And we have a little bit of distortion in this case. So I will not take the maximum value because the distortion is adding to the maximum. And I try to get this point. We have 58.4 volts. We have 437 watts bridged 4 ohms into the fronts and into the rears. And this divided by 2 is 218.5 watts per channel into a 2 ohm load, all 4 channels driven. Let me talk about the efficiency. And 2 ohms per channel, all 4 channels driven, we have an efficiency in continuous power 55%. It goes pretty down, and it's because my power supply is not delivering enough amps to the amplifier. But dynamically we have the same situation. We have the Rockford situation. We have way more than 60%, 63.8%. That's more realistic. Testing 2 ohms per channel dynamic power with just 8 cycles, and we have the situation that it shows again 64 volts maximum voltage. That's not true. I go to this point and take my cursor to this position. So we have 61.6 volts. I have 486 watts bridged mono 4 ohms, the fronts and the rears, and 243 watts into a 2 ohm load, dynamic power, 8 cycles, all 4 channels driven. Dynamic power testing with just 1 cycle, 1 kilohertz. So scope shows a maximum voltage of 68.8 volts. That's the maximum voltage the amplifier is able to do at 4 ohms. But I check out with my cursor because I have a little bit of peak distortion there. And I take this value, not this, but this one is realistic. So we have 67.2 volts. So the amplifier is doing 872 watts into a 2 ohm load dynamically. That's the value you can see in your punch verification certificate. They also measure dynamic power because we listen to loudspeakers and not resistors. You can read this text about the dynamic power in all of the old school manuals by Rockford. With just 1 cycle, the amplifier is capable of doing 1158 watts. I hope you enjoyed the video. If you like it, why not leave a thumb or subscribe to my channel? And if you already did, don't forget to hit the bell button to get informed for the next dyno video I'm publishing in the near future. So thank you very much for watching. See you next time for the next amp dyno. Bye bye.